So here we are given a function f of x equals negative 3x squared plus 1. It's a polynomial function, and more specifically it's a quadratic function. So first we're going to use the limit definition of the derivative to find f prime of x, and once that is done we'll find c for which f prime of c equals 0. So let's start off with the limit definition itself. So f prime of x is equal to limit f of x plus h minus f of x divided by h as h approaches 0. So first we need to write down the limit definition of the derivative. Once that is done, we know exactly what to do next. We need to plug in f of x and we need to plug in f of x plus h. So let's first see what f of x plus h is. So f of x plus h is basically taking f of x and replacing x by x plus h. Replace x with x plus h. That's all we've done here. Wherever you see an x, just replace it with x plus h. So we have x squared, so that becomes x plus h the whole squared plus 1. Now substitute f of x plus h into the limit definition. So negative 3 times x plus h the whole squared plus 1 minus the quantity negative 3x squared plus 1 whole divided by h. So this is equal to the limit as h approaches 0. We simplify x plus h the whole squared. So x plus h the whole squared is x squared. So square the first plus 2 times the product of the two, x and h, plus h squared. X squared plus 2xh plus h squared. Next step, we distribute the negative 3. We need to multiply the entire expression with negative 3. And we get negative 3x squared minus 6hx minus 3h squared. And then we have the plus 1, and then we distribute the minus. So that's how we get the plus 3x squared minus 1. Cancelling the common terms. So we have negative 3x squared, positive 3x squared, plus 1, minus 1. We get negative 6hx minus 3h squared divided by h. Factor the h out to get negative 6x minus 3h. Remember that the whole idea of doing all this that we did is initially when we try to substitute limits, we get a 0 over 0. And the 0 in the numerator and the denominator is because of the h. So that's what we're trying to do, factor the h out. And unless you factor it, do not cancel. Factor it out and then cancel the h. And once the h is cancelled, we can find the limit by substitution. So when we substitute, we get negative 6x minus 3 times 0. So that's negative 6x. So this is just a polynomial function. We've done many problems of this sort. But the next step, let's pay attention here. It says find c if f prime of c equals 0. So find c if f prime of c is equal to 0. Now f prime of x is equal to negative 6x. So we used the limit definition to find the derivative of the function negative 3x squared plus 1, and it is equal to negative 6x. So f prime of x is equal to negative 6x. F prime of c is equal to, now replace everywhere you see an x. So notice if this is an x, we see an x that's multiplied to negative 6. So wherever we see an x, we replace it with a c. So now f prime of c is equal to negative 6c. So we need to find c if f prime of c equals 0. So f prime of c is negative 6c. Set it equal to 0. And our next step is to solve for c. So when we try to solve for c, we divide both sides by negative 6. And that's equal to, c is equal to 0. So let's quickly look at what we did. We first found the derivative f prime of x using the limit definition. Next, once we found the f prime of x, so we said, okay, so here is the f prime of x. We need to find c if f prime of c equals 0. So f prime of x is negative 6x. F prime of c is negative 6c. Now, if f prime of c equals 0, so we set f prime of c to 0 and then solve for c. So the first step is to set it equal to 0 and the next step is to solve for c. So the derivative is 0 when x is equal to 0. That's what we've proved.